Everyone thinks Silicon Valley builds the world's best technology. But while the world watched software, China quietly built the fastest hardware innovation machine on Earth. Not a copy of Silicon Valley, not a cheaper version of it, something else entirely. And once you understand what that something else actually is, you will never look at a battery pack, a robot arm, or a semiconductor wafer the same way again. For 30 years, the story stayed the same. China wins because Chinese workers cost less. Factories move east because labor is cheap and regulations are loose. That story made sense in the 1990s. It even made sense in the 2000s. But it stopped being true a long time ago, and almost nobody updated the narrative. Labor costs in coastal Chinese manufacturing hubs have climbed for over a decade. Wages in Shenzhen and Suzhou now rival parts of Eastern Europe. So if the old explanation is dead, something else has to explain why China builds an electric vehicle battery, tests it, and scales it to mass production faster than almost any competitor on the planet. That something is not cheap labor, it is speed. Picture an engineer in Shenzhen with a rough sketch of a new sensor housing. In most parts of the world, that sketch takes weeks to become a prototype. You need a supplier for the plastic, another for the metal casing, a third for the electronics, and each one might be on a different continent. In Shenzhen, all three suppliers might be within a 20-minute drive. The engineer can walk out with a prototype by the end of the week, not the end of the quarter. That compressed loop from idea to physical object is the real Chinese advantage, and it has nothing to do with wages. This is where the golden fact comes in. The detail almost nobody is talking about correctly. China is not simply manufacturing more. China built a system where hardware iterates like software. In Silicon Valley, a coder can push an update, test it, and push another update the same afternoon. For decades, physical products could never move that fast because physical products depend on tooling, supply chains, and factories, which are slow and expensive to change. China cracked that limitation. Through sheer density of suppliers, parts makers, mold shops, and assembly lines packed into the same industrial zones, Chinese manufacturers built something close to software speed, but for atoms instead of code. Think about the scale for a second. In terms your garage can actually picture. A single major Chinese battery gigafactory can cover an area equivalent to over 50 professional football fields. That is not a warehouse. That is a small industrial city, built to produce enough battery cells to power hundreds of thousands of vehicles every single year. And it is not an isolated case. Multiple firms across multiple provinces are running facilities of similar scale, all competing, all iterating, all trying to out-execute one another in real time. Now here is a number that should stop you cold. In 2025, one single Chinese company, CATL, held roughly 39.2% of the entire global electric vehicle battery market. Not 39% of China, 39% of the entire planet. Add BYD's battery output on top of that, and you start to understand why so much of the modern electric vehicle supply chain quietly runs through Chinese factories, regardless of what badge sits on the hood of the car you drive. Robotics tells the same story from a different angle. By 2024, China had roughly 2,027,000 industrial robots actively working inside its factories, with close to 295,000 new robots installed in that year alone. That single year of installations represented over half of all new industrial robots deployed across the entire world. Silicon Valley builds robots that impress you in a demo video. China builds robots that quietly run 3 shifts a day on a factory floor you will never see, assembling the parts that eventually reach your driveway. So why does this matter to someone who just wants to buy a car, or a phone, or an appliance next year? Because this hardware machine is not staying inside China's borders. It is already inside global supply chains, inside components you touch every day, and inside decisions being made right now by automakers everywhere, including the ones building cars in your own country. Let's talk about Shenzhen specifically, because Shenzhen is not just another city on a map. 40 years ago, it was a fishing village. Today, it operates like the world's fastest hardware laboratory, a place where a single street can contain component suppliers for cameras, batteries, circuit boards, and plastic casings, all within walking distance of each other. When engineers talk about the Shenzhen speed advantage, they are describing a very specific phenomenon. You can source a part, test a part, and redesign a part within the same business day. Try doing that from a factory in the American Midwest, ordering components from 3 different countries, and you start to understand why iteration cycles in Shenzhen can move at a pace that looks almost impossible from the outside. But speed alone does not explain everything. The deeper weapon is vertical integration. In much of the world, a company designs a product, then hunts across the globe for suppliers to build each piece of it. In China's densest industrial clusters, many of those suppliers already exist next door, sometimes owned by the same parent company or tightly bound through long-term contracts. That means fewer shipping delays, fewer currency conversion headaches, and far less time lost negotiating with a supplier 8 time zones away. When you control more of your own supply chain, you control more of your own timeline. And in industrial competition, timeline is everything. This is also why batteries, robotics, electric vehicles, and semiconductors did not develop separately in China. They developed together, feeding each other. A better battery makes a better electric vehicle. A better electric vehicle demands more precise robotic assembly. Better robotics demand more advanced chips to control them. And better chips demand more advanced manufacturing equipment. China built an environment where progress in one industry directly accelerates progress in the next, creating a feedback loop that is very difficult for a country with a more fragmented industrial base to replicate. Now for the part almost nobody explains, honestly, because it complicates the easy headline. China has not caught up to the West everywhere. In advanced semiconductor manufacturing, the kind used for the most cutting-edge artificial intelligence chips, China still depends heavily on foreign technology. The most extreme ultraviolet lithography machines, the ones capable of etching the tiniest and most powerful chip patterns in the world, are dominated by a small number of companies outside China, and access to that specific technology has been restricted through export controls. Reuters reporting has noted the United States capped how many advanced artificial intelligence chips a major Chinese firm like Huawei could produce in 2025, limiting output to around 200,000 units, a hard ceiling imposed specifically because of that technology gap. That gap is real, but China is not standing still in front of it. Reporting indicates Chinese chip makers are pushing to triple domestic artificial intelligence chip output in 2026, and in that same year, domestic firms began mass-producing homegrown immersion deep ultraviolet lithography machines, an attempt to build independence from foreign tooling one generation at a time. It is not the most advanced tier of chip technology yet, but it is a serious, well-funded attempt to close a gap that used to look nearly impossible to close. Here is where the picture gets genuinely fascinating, because this is not a simple story of one country winning and another losing. It is a story of two completely different innovation philosophies running at the same time. Silicon Valley built its empire on software. Code is nearly weightless. It can be written, tested, and deployed to 1 billion phones overnight with almost no physical friction standing in the way. That model rewards small teams, fast pivots, and venture capital willing to bet enormous sums on ideas that might fail completely. China built something almost the opposite. Physical goods are heavy, expensive, and slow to change under normal conditions. So instead of trying to outcode the world, China built an industrial environment dense enough to make hardware behave a little more like software, compressing design, prototyping, and mass production into cycles that used to take years down into cycles that now sometimes take months. Silicon Valley perfected iterating on ideas. China is closer to perfecting iterating on machines. Ask yourself this: if the next decade of global competition is not decided purely by who writes the smartest code, but by who can design, build, and scale physical technology the fastest, which model do you think wins more often? That question is not rhetorical. It is the exact question automakers, battery suppliers, and electronics companies around the world are already losing sleep over. And this is not abstract theory happening far away from your life. Look inside the electric vehicle market specifically. Chinese automakers, powered by this exact hardware ecosystem, are now exporting vehicles at price points that are forcing legacy automakers in Europe, Japan, and North America to completely rethink their cost structures. Some of those legacy companies are responding by forming new partnerships with Chinese battery suppliers, licensing Chinese platform technology, or restructuring entire product lines just to stay competitive. That is not a future scenario. That is happening in boardrooms right now. So where does that leave the old narrative? The one where China simply competes on cheap labor and copies Western designs? That narrative is not just outdated, it is actively dangerous if you still believe it, because it makes you underestimate exactly what you are competing against. The real Chinese advantage in 2026 is not a wage gap, it is a systems advantage, built from supplier density, vertical integration, and an industrial culture that treats speed as a competitive weapon in the same way Silicon Valley treats disruption as a competitive competitive weapon. None of this means China has become invincible, or that it has replaced Silicon Valley as the center of global innovation. Silicon Valley still dominates the software layer of the modern world, from artificial intelligence research culture to platform businesses that generate enormous global reach with comparatively tiny physical footprints. China still depends on foreign technology for the most advanced chip manufacturing tools on Earth. Both of these things are true at the same time, and pretending otherwise, in either direction, only makes you worse at understanding where the real competition is heading. What China actually built is a parallel model of innovation, one Silicon Valley never had to build, because Silicon Valley never needed to master mass physical production at that scale. Software companies could change the world without ever operating a single factory floor. China took the opposite path, mastering the factory floor so completely that it turned physical manufacturing itself into a fast-moving, highly adaptive innovation engine. So the next time someone tells you China simply copies Western technology and builds it cheaper, ask them one simple question. If that were still true, why would a single Chinese company control close to 40% of the entire global electric vehicle battery market? Why would half of all new industrial robots installed on Earth in a single year end up inside Chinese factories? Why would automakers around the world be restructuring entire supply chains around Chinese battery and component suppliers instead of the other way around? The honest answer is that the game changed, and most of the world is still catching up to that fact. China did not become Silicon Valley. It built something Silicon Valley never needed to build. The world's fastest hardware innovation ecosystem, running quietly beneath the vehicles, the batteries, and the devices already sitting in driveways and living rooms around the planet. And that raises the real question worth sitting with. If the next major breakthrough in your own car, your own home, or your own pocket does not come from a piece of clever code, but from a factory floor moving faster than anyone outside it realizes, are you actually paying attention to where the real innovation race is happening? Drop your answer in the comments because this conversation is only getting louder from here. To make sure you are never caught off guard by what comes next in this industry, join us here at Driven to Distraction, where we keep pulling back the curtain on the decisions shaping the next generation of everything with wheels, batteries, and circuits inside it.